we're going to look at intercept form and how to graph it. We have the intercept form as the function of x equals a times x minus p times x minus q. Alright, so the a value is the same as standard form, so if a is positive, it opens upward, concave, another word for open, and a is negative, it opens down. Alright, so our x-intercepts are p0 and q0. So this way of writing the quadratic function revolves around our x-intercepts. Alright, so p being one x-intercept and q being the other. Also notice that p and q are opposite from what is in the formula. Alright, so just to take a note, alright, and there, they have negative p, negative q, and if you look at your x-intercepts, they're written opposite as positive p and positive q. So again, with x's in the parentheses, we're going to opposite whatever number is there, and that'll be the key to writing out these intercepts and using the vertex. We also have an axis of symmetry. Okay, x equals p plus q over 2. Alright, so our first example. Alright, so we have f of x equals 2 times x minus 3 times x minus 7. Alright, so we want to find the vertex first. Alright, well, let's list some variables really quick. Our a value is 2. Our p value, not b, our p value is 3. Okay, we're going to take out and make it opposite. And then our q value will be opposite of negative 7, which is positive 7. Alright, so the vertex. To find that, we're going to use the axis of symmetry again, which is just a different formula. So we have x equals p plus q over 2. Alright, so our p value is 3 plus 7 over 2, which is 10 over 2, and that gets us 5. Alright, so x equals 5 is our axis of symmetry. Looking at our vertex, that'll give us our x value just like before. Right. Now to find our y value, we need to substitute 5 into x. So we'll take f of x, f of 5 equals 2 times 5 minus 3 times 5 minus 7. Alright, and then you just work that out. 5 minus 3 is 2, and 5 minus 7 is negative 2. So you get 2 times 2 times negative 2. Alright, and all that would equal negative 8. So negative 8 is our y value. Alright, so let's go ahead and plot the axis of symmetry and our vertex. So our axis of symmetry is at 5, which is right here. Oops. Bring that back up. Hold on my pen wrong. X equals 5. Alright, and then the vertex is at 5, negative 8. So 1, 2, 3, 4, 5, 6, 7, 8 is right there. So that is our vertex at 5, comma, negative 8. Alright, direction. Our a value is a positive 2, so the direction is open up, or concave up. Alright, the roots. Again, look at your original formula. The opposite, your p term is 3, so your first root is going to be 3 comma 0, and your second root, your q, is going to be 7 comma 0. And those are your two roots. Alright, so let's go ahead and plot those as well. So we got 3, 0 right there, and we have 7, 0 right there. So we have our vertex, our two x-intercepts. We can go ahead and graph our parabola. Best you can, and there it is. Alright, so for the table, not much to use the table for with the axis of for intercept form. We can put our vertex in there, which would be 5, -8, and then we can just put like 3, 0, and then on the other side 7, 0, and that's the only points you really need. Alright, describe the transformation that occurred to the parent function to produce the graph. Well, we can get this from the vertex. Okay? So our vertex is 5, -8, which means we went 5, since it's positive, to the right, and then -8 is down 8. Alright, and that's where it transformed. Also, our a value 2, since 2 is positive, it's a vertical stretch. Right here. Alright, so 5 to the right, down 8, and vertical stretch by 2. Alright, and that's all there is to it for intercept form. So let's look at a problem here. Alright, so story problem, kicking a football. The path of a place kick football can be modeled by the function of y equals negative 0.026 x times x minus 46. Okay, where x is the horizontal distance in yards and the y is the corresponding height in yards. Okay, so if you look at the picture, we're starting pretty much at 0, the origin, and to the where it lands on the bottom. Notice that our max height is going to be our vertex there, where the box goes up, and our quadratic function is negative. Alright, so that's very common with projectiles, because because of gravity, it pulls objects down, so you'll get a parabola shape. So let's look at part A. How far is the football kicked? Well, what we're going to do is we're going to use our intercept function, because that's what this is in. So f of x equals a times x minus p times x minus q. Alright, so let's list our variables. What is our a going to be? Well, a in this case is negative 0.026, okay, which is consistent with it opening down. Our p is going to be opposite our p value. Well, since we have x here, your negative 0.026 is your a. You really have x minus 0, and then you have x minus 46 here. Okay, with that x alone is minus 0, so you don't need the 0, so they don't write it. So your p term is actually 0, and then your q is opposite of negative 46, which is 46. Alright, so then how do we solve this? They want to know how far the football is kicked for part A. Well, if one intercept is at the beginning, right there on the picture, and the other one here, Okay, those are your two roots. Root, another root. We can use that to tell how far it is. So obviously our first root is 0, and then this one here is going to be 46 yards. Okay, so to find that, um, your distance the football was kicked is going to be 46 minus 0, which gives us 46 yards. Part B, what's the football's maximum height? And for that, we're going to use our axis of symmetry, AOS. Alright, we have to use the formula of x equals p plus q over 2. Alright, so then we substitute our values in. So x is going to equal 0 plus 46 over 2, which is just 46 over 2, and that gives us 23 yards. So with that 23 yards, that is the halfway point. Alright, so if we look at our vertex, we have distance, comma, height. That's pretty much what it is. So we know this is 23, so we need to find our height, and that'll be how high the ball is kicked. And we just simply substitute the 23 for our x value. So we get y equals negative 0.026 times 23 minus times 23 times 23 minus 46 from our equation. And then when we compute that, we get 13.8 yards. Let's put that out. So the ball will be kicked 13.8 yards high. Which is our maximum.